A couple of weeks ago, I presented a video whereby I show viewers how to convert their Next.js or React application from NPM or Yarn over to PNPM. And people were curious about the infinite scrolling application that was in the video. I created this Next.js application several years ago to test out the intersection observer API, and more specifically the React intersection observer npm library. And I used that in conjunction with TanStack Query. Of course, several years ago, TanStack Query was referred to as React Query. The name, of course, has changed since then. And the whole project was just to vet out certain technologies to use in conjunction with Next.js. And so it is simply just an application whereby if we scroll down and we cross a certain threshold, we get um, a certain amount of DOM elements loading. Just a very vanilla infinite scrolling application. And of course, the color is just random color generation using just basic JavaScript coding. I know that several of my viewers and some of my associates have asked me how I generated those DOM elements with the sequential time and the random coloring. Well, it's quite simple. Whenever you use Next.js and you use the scaffolding from the CLI, it will scaffold a project structure, basic project structure for you, and it will generate an API directory within the pages directory, and it will generate a file called like hello world.js or something like that, whereby you can set up your API. In my case, I created product.js, and I'm using the JavaScript constructor array function to generate some array elements, and I fill it. I out of the box, I don't fill it with anything, and I map through it, and I fill it with um, sequential time by calling the date constructor. And that's pretty much it in terms of generating those random time. And then on the front end, to get the to change the color, I'm using for the background color, I'm using this HSLA. HSLA is hue, saturation, lightness, and alpha. And I'm multiplying the ID by 30, just a random number, to generate those different color. But I can assure you that this is a very esoteric, very contrived example. It's not very useful at all. Um, in this video, I'm going to show you how to create a Next.js application with infinite scrolling, and we will be using the TanStack Query library and the React Intersection Observer library to help us along. Now, uh, there's a whole lot of green in this application because of St. Patrick's Day, which is just around the corner. Of course, in your own application, I will show you how to generate whatever color you like. My current settings are that we are going to hit the server on every fifth product, and I have a limit to 25 products. And of course, I will show you how to adjust that as necessary. And here we are at the beginning of the list, and I've added this here because I'm going to demonstrate how to go backwards as well as forward. So if we were to scroll down, hit the fifth one, you know, load some five more, load another five more, load another five more, and then on the 25th product, it'll stop. Again, I'm going to show you how to adjust that, and we can navigate to a different page. Of course, we have the obligatory Taylor Swift jokes, and back to our app. Here's what I mean by going backwards. So let's say on initial page load, I start out with the sixth product in the catalog. Well, what if I want to go back in time? Press a button and it loads the previous five. Of course, you can set it up however you like. The React Intersection Observer library is used to detect when we cross the threshold. So on the on every fifth product, as I scroll out of the viewport, the library is detecting where the elements are in relation to its parent element, and it's automatically generating the next set of download for us without having to press any button. And with respect to the TanStack Query library, I'm using their useInfiniteQuery hook to control how many products I load uh, at a time. In this case, I have it set up to 5, and then I'm controlling how many products I want to load overall. In this case, just 25. So therefore, in essence, I'm using the TanStack Query use infinite query hook to work with the API to give us infinite scrolling. I also have a GitHub repo for you with two branches. The main branch is the completed branch, where it's ready to go. The starter branch is the branch that is bare minimum. If you want to follow along, you can switch over to that branch and code with me. Now, I am giving this away for free. I am not trying to sell you any Udemy courses or anything like that. I'm not trying to sell you anything. Okay, I'm just giving away knowledge for free. So if you're not a subscriber, please consider subscribing to my channel. It doesn't cost you anything, and it'll help me grow the channel. Thank you. Let's have a look at the API that we will be working with and get an understanding of the shape of the data that will be coming back. DummyJson has been a fantastic free API that I've been working with. There are no sign-ins and no registration whatsoever. And the uptime has been 100% ever since I've been working with it. Have a look at what that API serves up to you. If you took my Vika React server-side rendering Vika tutorial, you know what its offerings are, and this is the type of product that it serves up to you. Like any good API, DummyJson offers you query string params. Of note is the ability to limit skip, which is very important for pagination and infinite scrolling, and the ability to select only the resource on the endpoint that you need. In this, for example, if you only need the title and the price from that resource, you only bring back these two and not the 50 others that you do not need, thereby saving you bandwidth. It also offers you a Swagger-like interface so that you can um, uh, preview. Let me show you what I mean. So here I am in Postman, and I am hitting the products endpoint, and look at how much JSON there are on this resource. And it's bringing back, I believe, the first 75 records. And from the app, you can see that all we need is the product name, the ID, and the thumbnail image. Again, happy St. Patrick's Day. Either St. Patrick's Day or Shrek, just in case you don't know who Shrek is. Jumping back into Postman, so you can see here, I've set the query string parameter to limit of 25 records, skip 0, and then select title, ID, and thumbnail. I misspoke earlier. I meant to say title, not name. Anyhow, the ability to skip is important for pagination and for infinite scrolling. And DummyJson gives us that ability. And if you're using this for a production application, obviously you need to have the backend developers built in the ability to skip in the query string param. Now, before we jump into the code, there are a few concepts that I would like to explain first, so that it won't be so overwhelming for you when we start coding. My channel has a very wide audience. So if you're already a 10x programmer, and you want to skip ahead to the good parts, use the timelines in the description of the video. The Intersection Observer API provides a way to asynchronously observe changes in the intersection of a target element with an ancestor element, or with a top levels documents viewport. The Intersection Observer API allows you to configure a callback function, obviously in JavaScript, that is called when either of these circumstances occurred. One, a target element intersects either the device viewport or a specified element. That specified element is called the root element, or root, for the purposes of the Intersection Observer API. Two, the first time the observer is initially asked to watch a target element. This implementation of the Intersection Observer API is in vanilla JavaScript. And, and even with the availability of the Intersection Observer API, look at how much code we have to write to implement it. And then have a look at the DOM. That's why I use the React implementation of the Intersection Observer API, which wraps all of this stuff in a nice hook for us. You can use the Intersection Observer API for multiple scenarios. But for the purpose of this video, we will be using it for infinite scrolling. The React Intersection Observer NPM library has been around for a while, I believe between 7 to 8 years, and it has a decent amount of weekly download, and the supporting documentation is outstanding. You can see the README here. The README is actually quite useful, and it goes through a lot of the same stuff that is on the official GitHub repo. And to top that all off, they also have a storybook site to where you can preview the hooks that you can use. In this tutorial, we will be using the useInview hook from the library. The way that we will implement it is that we will not need any optional options, but we will be extrapolating or destructuring out the ref module and the InView module. Let's have a sneak peek inside the app. So ref and InView from the hook. InView means exactly that. Whatever DOM element is in view within the viewport. The ref is the reference to the DOM elements that we want to monitor, and of course the hook will report the status. If you recall, when that fetching button that we saw in the UI, when I scroll down to hit that button, that button is where I attach the ref to. And just as a reminder, gonna hit that button, gonna hit that button, gonna hit that button, gonna hit that button. There it goes. See that? That loading ellipsis, see, that button is what I attach the ref to. So just to drive the point home, let's go to Storybook for the library. So if you notice here, up here in this button here, it says in view false, right? But if we scroll down to where the ref is attached, see that? See how it changed? Out of view, in view, right? So if we attach the ref down to here and we reach that threshold, when we reach the threshold, it changes and it loads the next set. Um, as we continue to work this tutorial, it'll make more sense. The next concept I want to get into is the concept of a cursor. Now, if you are a backend developer, you're used to developing APIs for the front end, you're probably already square away with that concept. But if you're a front end developer for all of your career, you might not be familiar with the concept of cursor, which is used with pagination along with infinite scrolling. Now, a cursor is a string type created by the server using whatever method it likes that divides the list of results into those that fall before the cursor, those that fall after the cursor, and optionally one results that falls on the cursor, right? So from that description, you can tell that there is a divide and conquer strategy here, right? So that we can load up data in chunks. There goes my alarm. So that we can load data in chunks so that we don't overwhelm the user's bandwidth with data. Let's have a look at a practical example. So here we are back in the code, and I have logged out the request object. Now please keep in mind that this is a Next.js application. It renders on the server side. It is a server-side rendering React application. So whenever you log something out, at least from the API side, you have to look for it in the terminal, not in the browser. Okay, so make sure that you have your terminal open. Anyhow, so um, the request object contains a query property, and the value for that property is a cursor. Actually, the value is an object with cursor and a type of zero, a value of 0, which is a string type, as you can clearly see there. Um, so that's why on line 6, I've costed that value to a number, right? And just to drive the point home, let's have a look at what the value of cursor is after it's gone through the data costing and parsing the integer. I don't really hate Taylor Swift. She is annoying though. So as you can see here, now the cursor is at a number type of 0. So based on what I've just demonstrated, one way to describe a cursor is it is a reference point, if you will, for us to decide where and how much data we want to load to the front end so that we do not overwhelm the bandwidth of the end user. The final thing I want to get into before we start coding is TanStack Query. Now, TanStack has multiple products now, but the thing that I want to focus on is the query part, the data fetching from an API part of it. A few years ago, we used to run native JavaScript fetches inside of a useEffect hook, and that was causing issues, to put it mildly. Now, even Meta or Facebook themselves, of course, Facebook is the creator of React, um, they even recommend not doing that anymore and going with something called TanStack Query. Now, they're saying React Query here, but that was the old name. Um, as you can see here, React Query is TanStack Query. Uh, they need to update documentation. I might do a PR on that. I did make a video on how to use TanStack Query for full CRUD functionality. If you want a refresher on that, you can certainly read the TanStack Query documentation, or you can look at my example app in my um, my GitHub repository. I do have a GitHub repo for TanStack Query CRUD operations. For fetching data from an API and for infinite scrolling, we will be using just one hook from TanStack, and that is the useInfiniteQuery hook. And the reason why they designed it like this is so that the learning curve is manageable. If you already know how to fetch data using TanStack Query. So now that the conceptual explanation is out of the way, let's get into the code. I am currently in the starter branch of the project. Now, in lieu of ESLint and Prettier, I am using Biome as both linting and Prettier. Two for the price of one. As you can see here from the pnpm lock file, I created the app using the pnpm create next app and then the name of the application. And it'll walk you through a series of prompts. I prefer pnpm over npm and yarn. And as you can see on line number 6, I opted in to TurboPack for the dev environment. Of course, you have that option now. I have videos about TurboPack. In the starter branch, I deleted all the non-essential files. I just kept the global styles, the index.js file, and the hello.js file that came by default whenever you spun up a Next.js application. This would be the file that we will use to interact with the backend. It is in the automatically generated API directory. Let's go ahead and rename the hello.js file in the API directory to products.js, import Axios, and create a skeleton function to interact with the API. In case you're new to Next.js, any file that is under the API directory will be mapped to /API / whatever resource name you have. In this case, we will have a products um, resource because we call this file products. So this would be what the end products look like. No pun intended. See, API products. Let's capture the cursor from the request object. we are going to add two more constants, page size and max products. Page size will be the amount of products that would be loaded initially, and the amount of products that will be loaded when we start to scroll after the threshold. The max products constants represent the amount of products that we will be retrieving from the API overall. The next constant is a check or a control flow, which is not a way of saying if-else statement. Uh, Basically, we want to stop loading once we scroll uh, towards the end, which in this case is 25 products. So we want to stop loading once we've loaded the last 5 products. Go ahead and add a try catch block for this async function. I hope it's making sense now as to why I went through the concepts first before we started coding. So please add a GET request to the DummyJson endpoint. As you can see here, we are forming our requests exactly how I had shown you earlier in Postman. Since we are able to specifically request the title, thumbnail, and ID from the endpoint, we can create a constant called data and just map out exactly what we need. Go ahead and add a constant called next ID. It will be another ternary. So this ternary will calculate the next cursor position by adding the adjusted cursor, which essentially is the current cursor, to the page size. And if this new cursor position is less than the maximum number of products or max products, it sets next ID to this new cursor position. Otherwise, it sets next ID to null, indicating that there are no more products for us to fetch. This will allow the front end to know whether there are more products available, and if so, what cursor value should be for the next API request. Please add a previous ID constant, which would be another ternary. So this ternary calculates the previous cursor position by subtracting page size from adjusted cursor, which essentially is current cursor. So if this new cursor position is greater than or equal to 0, it sets previous ID to this new cursor position. Otherwise, it sets previous ID to null, indicating that there are no previous products to fetch. This will allow the front end to know whether there are previous products available, and if so, what cursor value should be for the previous API request. So essentially, previous ID is what allowing us to scroll upwards, to scroll backwards. And then on line 31, we are calling result.json, and then we are sending the title, the ID, and the thumbnail image to the front end, to the client. And then the next ID, which is the cursor value for the next page of products, or null if there are no more products, and the previous ID if we wish to scroll backwards, the cursor value for the previous page or products, or null if there are no previous products. Now keep in mind that on the API side, all products or in numerical order. It starts at 1. The ID starts at 1. It's all in numerical order. And then I wrapped the results.json call on line 31 with a set timeout to 1 second so that we can actually see the intersection observer library doing its work. Otherwise, it's just way too seamless. When it crosses the threshold, it handles that so elegantly that we won't see much of a change. So that's why I added the timeout so we can actually see it in development. Obviously, in the real world, you would want to remove this timeout in production. And then in terms of error handling, I just have very basic error handling. I'm just setting a 500 to the client if something goes wrong. At this point, we are done with the backend. And as you can see here, I've console log out data, which is what we're fetching from the endpoint. And again, since this is the backend, when you console log stuff out, it'll be in the terminal, not the browser. And so here's data, and here's the uh, array of objects that we're bringing back. Remember, we're just loading the first 5, right? The first 5, because page size is 5. Let's start working on the front end in the index.js file. Let's import the link and head Next.js modules. Since we already installed TanStack Query, let's go ahead and import Query Client and Query Client Provider, which we will need to wrap our Next.js app with that. And of course, I like to have the debug tool. Um, this is the TanStack Query Devtools, which is useful for debugging TanStack, obviously, and of course our CSS style. So off screen, I added a components directory under source, and in there, for now, I just have like a dummy component called infinite scroll, and then I import that in index. And then we new up the query client constructor and assign it to the query client constant. And then I brought in the Next.js head module, which will give us all the head elements in the HTML page. And then we wrapped the main component, in this case, infinite scroll, with the query client provider from TanStack. And then the current client, excuse me, the query client provider takes a client prop, and then we pass to that client prop the query client that we declare here with the query client constructor. And then the React query DevTools is instantiated here. And when you have this prop, that means it will be automatically turned on while in the development environment. Of course, this pattern is a very standard Next.js slash React pattern for bringing in major libraries. Nothing groundbreaking here with regards to the infinite scroll components being in its own separate components directory rather than pages. That's just something I decided to do. You don't have to, you don't want to. Next, let's implement React Intersection Observer. So as you can clearly see that on line 35, I am using the useEffect hook. And the reason is because the useEffect hook is used with Intersection Observer to manage the life cycle of observing elements. And in this case, whenever we fetch the next 5 or the next 10 or the next 15, whatever it is that you want to fetch. So it allows you to set up the observer when the component mounts and then clean it up when the component unmounts. and that will prevent memory leaks and ensure correct behavior. So obviously we're going to be watching the um, fetch next page and then the in view. So remember when I demo how the React intersection observer worked earlier, right? When we scroll up and down to determine whether it's in view or not. So that's why I'm adding this check here. And then we went ahead of ourselves and I went ahead and I could declare a button. Now, it looks like I'm calling it a button, but it's not really a button, right? Because we don't actually interact with it. Um, but really, you can change this to whatever DOM element you like. But this is just as a fallback in case you want to do pagination. But for this reference point here, the ref will be the button. Let's have a look again in the UI to reinforce our learning. Let's import modules that we need for this infinite scroll component. I'm bringing in fragment and useEffect from the core React. We are not using useEffect to communicate directly with the API, and I'll show you that here in a moment. And I'm bringing in Axios to communicate with the API. Now, if you're new to server-side rendering and new to Next.js, you might be wondering, well, why do I need Axios on the front end, on client-side component? Didn't we already fetch data from the server side in this products API page? Yes, we did. This Axios is used to communicate with our backend because this is a server-side rendering application. We have a backend and a front end, and this Axios in the front end here is used to communicate with products. Remember when I show you in the browser the root for this page, this resource? Here's what I mean, right? So our front end in the scroll component, we're making a call to our backend, our own local backend, to this root here is /API/products. This JSON is offered to us to the Next.js front end via this route here. Okay. Of course, we're using in the useInView hook from React Intersection Observer. We went over this already during the um, concepts portion of the video. And of course, we're only bringing in one hook from TanStack. Let's destructure the two modules that we need from the useInView hook ref and InView. And so I have destructured out the modules that I need from the useInfiniteQuery hook. If you're new to TanStack Query, this part might be perplexing to you. But essentially, I'm just importing in via composition the part of the TanStack library that I need to do all the work for me. If this wasn't available for me to compose in my function, then I would have to write all the code myself. If you are coming from React, excuse me, if you are coming to React from Angular, in Angular you have something called dependency injection, which works in a similar way, but composition is more efficient, in my opinion, because JavaScript, at the end of the day, is a functional language. Yes, there are classes in JavaScript, but that's just syntactic sugar. JavaScript has prototypal inheritance, not the classic OOP pattern like Java or C Sharp. So um, this is don't be afraid of this. This is just if it makes you happy, just think of it like dependency injection (DI). But really, this is composition, okay? And um, the more of these modules available to us, the less coding that we have to do in the end. And so the standard pattern for a hook from TanStack is to have a configuration object inside of the function call, right? And the first one is the query key. So the query key is a unique identifier. If you watch my complete tutorial on TanStack Query, you already know this stuff, but for people who didn't bother to watch that video, I'll give you a quick synopsis. Products is a unique identifier for this query. Now, if you were to fetch customer data or warehouse data, then this key would be warehouse data or customer data. And then the second signature for this function call is the query function itself. Remember, in JavaScript, functions in JavaScript are first-class citizen. So you can pass a function to a function in JavaScript, and really with any functional programming language. So this function here, this um, obviously in here it would be an async function, but you can use a promise with a donnable as well. Uh, Either way, it'll be async, right? Just how you want to go about it. Obviously, TanStack Query is a promise-based library, so therefore it would be async. Now, this function is to go fetch data. In this case, we're fetching data from here, okay? Not from the API, but from here. So now you can extrapolate all of this out to a separate custom make hook, and then you can pass that in here to make it less codey. And here's the function itself. We're going to hit this resource in here, and then we're going to return the data. And then on line 29, I am declaring an initial page param field with a value of 0. If you recall from the demonstration of the app I did earlier, when I was scrolling backwards, if you want to test that functionality out, you would change the value from 0 to 5 if you want to start the initial load at product number 6 and forward and onward. Same if you want to start at product number 11, we change this to a 10, right? And then you scroll backwards. That is a rare use case scenario, admittedly, but I'm giving you that option if you want it. So finally, within the useInfiniteQuery configuration object, we need to declare two functions. And these two functions will be used by the hook itself, and it will work in conjunction with fetch, dang it, fetch previous page and fetch next page. Let's start with um, get previous page and see how the hook uses this function to work with the get previous page. So the hook manage the infinite scrolling state and determine whether there are previous pages available for fetching. When the fetch previous page function here is called, it uses the value returned by the get previous page param, obviously this function here, to fetch the previous set of products. And then get next page, well, guess what? The hook uses this function to work with fetch next page when that function is being called. Here we are in the UI. I'm about to cross the 5th product, crossing the threshold. I hit the button, it's loading more. So that's what the useEffect hook is working with the observer API to do. Okay. We in view, it loads more. Okay, and then we get to the end and then it stops. And then the useEffect hook is watching the in view state, crossing the threshold, and whether or not we need to fetch more items so that we don't have a memory leak. Let's move forward to the JSX portion of the app. So straight out of the box, TanStack gives us some promises method to handle the where the promise is, the status, the data that's bringing back, and if there's an error, handle the error. This concept was created before there was suspense in React, but essentially this is their own implementation of suspense. Um, so nothing out of the ordinary here. We are just very basic handling of states straight out of documentation. Let's work on this button here. Obviously, this button is disabled at this point because we are loading the first um, 5 products from ID 1 to 5. But if the programmer were to set the initial page param to say 5, then this button would be enabled. So for example, I've set the initial page param to 10, so therefore this button is now enabled, and now obviously it will start at 11. But if I were to scroll backwards, it'll load the previous 5, right? And then if I clicked again, it'll load the last 5. So now we are at the beginning of the list. So let's work on this logic. By the way, I turned the bright green background off. You're welcome. Implementing the functionality of the button is actually quite easy. We add an on-click event, and we pass a callback function for that on-click event, and then we call the fetch previous page function that we extrapolated from the hook itself. So everything that we use here is actually from the hook, from the action of the event handler, as well as when to disable the button. Everything is coming from the hook. So very simple. As far as the text for the button is concerned, again, we are using these booleans value from the hook itself. And then we apply just a little bit of logic as to which text to render to the user, right? It's pretty straightforward. Nothing too complicated there at all. Next, we will be mapping through the data that we fetch here and then populate the data value here. So we will be mapping through that and rendering the product data in this part here. Before we code, if you recall in the API directory of our app, in the products file, we return JSON with the data, the next ID, and the previous ID so that we can do scrolling. As a result of that, the return JSON is nested. See that? Pages, data, so it's rather nested. So because of that, we are going to get the data pages, and then we are going to run flat map to flatten out that data structure to one level. Flat map, of course, is an array method, and then after running the predicate function inside of it, it will return an array. And because of that, we can chain on a map function to it. So therefore, we avoid having nested maps, which are essentially nested loops, right? Because these array higher order functions or map filter, all of that, they're just loops. So we want to avoid O of n O of n square time. We would want to avoid a quadratic runtime. So that's better. Chaining one array method to another is better than having nested array method. If you would like to learn more about flat map in JavaScript, I made a video 4 years ago here. And some of you more experienced TypeScript and JavaScript developer might be asking yourself why I'm not using optional chaining or nullist coalescing in the code. I will, but during development, I actually want to see error. Optional chaining and nullist coalescing, the point of that is to not error out the application where there's no data, which is great for a production application. But there's also a double-edged sword in that if you hide the error during development, you might not know the error exists. And so when we get further along, I will go back and we will add optional chaining as well as uh, nullist coalescing. Now, if you don't know what those terms means, don't worry, I'll cover that for you. Finishing out the rest of that DOM element. So I have a class, CSS class for the product. Now this style, inline style here is for the green St. Patrick's Day background color. Get rid of that if you want, or adjust it as you like. Of course, we're going to need a key, right? Because we're looping through we're mapping and looping through the data. We're bringing out the name. Now, I'm just using a paragraph tag with a couple of break tags for the product name and the product ID, but certainly, of course, the image, but certainly you can use something like use semantic tags here, like figure or fig caption, something like that. I'm just doing this for expediency. Okay, so this part here from 62 to 80 is where we load each individual products, right? We're looping through data and looping five at a time. Um, Reloading five at a time and then rendering it. It's been a long day, man. Okay, so the next section will be the load more section. So the next button, the bottom button, is not unlike the previous button. We um, we attach a ref to the bottom button so that we can monitor the threshold. I mentioned that earlier. And then we attach an event listener to fire off um, the fetch next function, which comes with the hook. And then for disabling the button, we are using the two booleans value that comes with the hook. And then we have conditional logic as to what text to render within the button. Of course, I'm calling this a button, but we don't actually click on it, right? When we scroll down, it crosses the threshold, and then it loads the next set of five products until it gets to the limit. And finally, I'm adding a section to inform the end users that the background is updating when they cross the threshold, and we're fetching data. We don't need this fragment because I am not putting any IDs, assigning a prop of ID in the fragment literal. So we can just go with that without having to pull in the fragment module from React. And then off screen, I added um, an about component within the pages directory so we can link to it. And then it just to demonstrate we still have the ability to navigate between different views. So here's the final product. Certainly you can adjust the amount of products that's going to be fetched every time, and then you can also adjust the overall amount of product that's you're limited to. And of course, you can certainly adjust the hideous green background to whatever color you like. Let's test the navigation to make sure that it works. Also, if you use my GitHub repo to learn this stuff, um, I'm going to show you how to get rid of the Next.js dev tool as well as the TanStack dev tool if you don't already know. So to get rid of the Next.js dev tool in the browser, go to next.config.mjs or mts, whatever the case may be, set the dev indicators to false, and the dev tool will be gone permanently. Now, if you like the dev tool and you want to get rid of it only per session, then you can do that in the UI itself. With the TanStack Query dev tools, it's a bit different. Now, in the cogwheel, you can set the position and you can detach it from the browser, but it's still there. And then closing the detach tool will simply just dock it back to where it was before. You would think that if you were to pass the initial is open boolean to false, it will go away entirely, but it doesn't quite work like that. Now, this will only render in dev environment. It doesn't render in production environment. But if that dev tool is annoying you, number one, you don't have to download and install it, right? I mean, it's a separate the dev tool is a separate npm package from TanStack Query itself. But if it's annoying, you're having a bad day that's annoying you, you can just simply comment it out or just get rid of it entirely, and it'll be gone. As I promised earlier, I went back and I added um, optional chaining to flat map to make sure that the data is there before we run a flat map on it. And for knowledge coalescing, if there's no data there, we just return an empty array, um, so that it doesn't crash out the entire app in production. Obviously, you need to have some sort of site reliability monitoring to make sure that if data is missing or there's a silent but deadly error, then that needs to be a hot fix, right? So we don't want that silent error, high silent errors. That's not a good thing either. And then of course on line 76, notice coalesce it to like empty string so that the image uh, doesn't appear like broken. Um, okay, we don't crash out the app because we have like a missing image. Sometimes the missing images could be not our fault. It could be the fault of our cloud provider. That has actually happened before, believe it or not. And then in the products.js file, added optional chaining uh, after data to make sure the data is there in the response object before we map it. And then if there's no data, then we render an empty array, give them an empty array. Again, caveat emptor. I left comments in the finish branch, in the main branch, for adjustment if you need to adjust fetching the amount of product. Okay, it's not too bad, right? I mean, considering that I went into detail into the concepts. I think the actual tutorial itself was about 20 minutes, maybe 25 minutes. The rest of the time was actually spent explaining very detailed concepts for intersection observer API, some TanStack query stuff, and some Next.js stuff. Okay, my friends, thank you very much for watching this video. If you enjoyed the video, please give it a thumbs up. If you're not a subscriber, please consider subscribing. It doesn't cost you anything and it'll help me grow the channel. I'm trying to get to 1,000 subscribers. Right now I'm at around 915. Thank you for watching again and have a great day. I'll see you next time.